Alright, so tangents and normals. Do you guys remember what number this is?
I think it's number 7.
Number 7. Let me just move that out of the way. So number 7. Okay, so basically tangents and normals. We're gonna just start with the tangent itself, and then I can explain what a normal is. But a tangent, this is a line that just touches any type of graph or shape. Okay. In our case, we're going to be dealing with graphs. So a tangent is a line. Now, keyword there is line. All right. Why is that the keyword? Basically, I'm relating it to your linear functions. You have to know the equation of a line. You have to know its structure. You have to know gradients. You have to know intercepts. Okay? A tangent is a line that touches a curve, and more generally, any shape or a shape. Not exactly, sorry. At one point, by skimming across it. Okay, now I'll show you a visual, I'll give you a visual aid so you can understand what that means by skimming across it. So for example, I've got this, let's say we've got this curve on the XY plane. Yeah, so have a look. Say we've got this graph here, whatever it is. It doesn't really matter what it is. We'll just call it y equals f of x. Now, a tangent at a particular point, let's say this point. I want to do a tangent at this point. Any guesses as to how this may look?
It's a straight line.
Alright, so basically it's related to what? The gradient. You remember how we said that calculus is all about gradients? It will give you the gradient at exactly this part here. And furthermore, since we're doing actual tangents, we're going to find out the equations as well. So this orange line here, this is your tangent. Okay, and that's what we're going to be discovering today. Now, like I mentioned to those of you who started calculus with me from scratch, if you remember, what's another name for the derivative of a function?
Gradient.
Gradient function, okay? So the derivative of a function is also known as a gradient function. So basically with that, we will be using gradient functions to help us find the gradients of tangents. Okay, so we'll be using gradient functions to help us find the equations of these tangents. Okay. Now, if you guys don't know, you can't read what I'm writing, that's fine. You just have to refer back to it later on the video if you just want to complete your notes properly, or you can just use my notes and highlight whatever you need to. Okay, now let's start with some basic examples. Now watch this. The question will be worded as such. It will say, find the equation of the tangent to the curve y equals x squared at the point 2, 4.
Then you just have to differentiate that and subject x.
Yes. Okay. So let me show you. I want to show in every single way how this works, and I want to show you why it will become whatever it's going to become. Okay. So when I draw this on the xy plane, guys, we have y here, x here, and I shall draw this somewhere here.
Do I have to draw it?
No, you don't have to draw it. I'm showing you to help you when you're doing some revision at home or when you're looking back at the notes. So here, y equals x squared. I want to find the tangent at 2, 4. Notice that 2, 4 lies on the graph, correct? 2, 4 is on the graph itself. So we want to find the equation of this red line here. Does that make sense?
Yep.
So the blue line is y equals x squared. And the red line is our tangent. And this is what we want to find. Sweet. Alright, so let's move on to working it out. So, the first step, watch this. Step 1. Differentiate the given function. So, the given function is y equals to x squared. What's the derivative of y equals x squared, guys?
2x.
Okay, so it's 2x. Let me just change this color. Style. Alright, so the function is 2x when we differentiate. So dy dx. How can the 2 units write it?
Y dash.
You guys can write as y dash, but if you're in 3 unit or 4 unit, don't you dare write 2x. Y dash, sorry.
What if you do 3 unit but you need 2 unit?
No, just don't. Alright, so now we have dy dx is equal to 2x. This is my gradient function. Now question, guys. What is the gradient function in terms of?
Dy dx.
No, that's the subject. What's it in terms of? It's in terms of x. So how do I find the gradient of my tangent?
Sub x.
We sub in the x value that they have given us. And what did they give us? They gave us 2. You see that? I will use that x value to find my gradient of my tangent. So watch this step very carefully, guys. Right now, dy dx is a gradient function. When I sub the x value in, it becomes a tangent gradient. Okay? So let me write that down as a step. When I sub the actual value in, it becomes a tangent. So step 2. Substitute the given x value in. Okay? So that makes it x equals 2, because that's what was given to us. We mentioned that earlier. And I no longer write dy dx, guys. dy dx becomes m. So take note of that. dy dx becomes...
So that's after you differentiate, yeah?
after you sub it in.
Oh.
Okay? dy dx becomes m. Now, you see that little t that I wrote there? That's just for me, so I know that I'm talking about the gradient tangent. Okay? So dy dx becomes gradient of the tangent when x is substituted. So that with this, I'll write mt equals 2 times 2. Got it? So that is 4. Now that means that, see this red line over here, guys? That red line there, that has a gradient of 4. So far, so good? Alright. Now, in order to find the equation of a line, because now I want to find the equation of this red line. In order for me to find the equation of this red line, I need to use which formula?
1 minus y1 equals m bracket.
We need to use y minus y1 equals m bracket x minus x1, because that's the equation of a line, and I have a point. Look at that. I have a point here, and I have a gradient here. So we use the point gradient formula. So step 3, use the point gradient formula to find the equation of the tangent. Okay. So the formula is y minus y1 equals m bracket x minus x1. Lucky for you guys, it's on the formula sheet. Year 10, did you know about the reference sheet at all? Yeah. Okay, so it's on the reference sheet, so you can refer to that. Your x1 and y1 are here, x1, y1, and your m is your mt. So now we have y minus 4 equals 4, x minus 2. Expand that, make y the subject, put in general form, however you want it. Just make it look neat now. So y equals to 4x minus 4. That's your final answer. So see this red line over here, guys? This red line has equation y equals to 4x minus 4.
So we don't have to put in general form.
You can if you want. So right now this is in gradient intercept form, or 4x minus y minus 4 equals 0. That's in general form. Now, you will know which form to put in based on the question. If the question says something about perpendicular distance after it, then you will put in general form. Okay? But if it doesn't mention it, you don't need to go to that length. Okay, so basically there's 3 main steps here, guys. Let's try another question. This time I'm not going to give you the complete point. I'm going to give you just the x value. Okay? So that was example 1. I'll give you example 2 now. So find the equation of the tangent to y equals to x cubed minus x squared plus x minus 1 when x equals to, let's say, negative 1. Okay, so what did I do here that's different to question 1? I did not give you the y value here. So when I see a question like this, the first thing that you should do, guys, is get me that y value. Make sure that's the first thing you do. You sub the x value here, sub this into here, and get your y value. So that's what we'll do right now. So sub, oh my god, it's still black. Sub x equals negative 1 into y. So we end up with y equals to negative 1 cubed minus negative 1 squared plus negative 1 minus 1. And I'm encouraging brackets, guys, for your substitution, so don't make any silly mistakes. So with that, we get negative 1 plus, no, that's a negative. Negative 1, negative 1, negative 1, negative 1. So we have the point, negative 1, 4. So therefore the point is negative 1, negative 4. Okay, so now I've got a point. What do I need next? I need a, what's the correct word? I need a gradient. So yes, we find the gradient by differentiating. So now we do dy dx is equal to 3x squared minus 2x plus 1. Alright, so those of you, just picture me differentiating this. Alright, just do it in your heads real quick and make sure it makes sense why I got this answer here. Okay? Now, what do I need to do to find the actual gradient of the tangent? So sub x equals negative 1 into here as well. This will give me the gradient of the tangent. So what does dy dx become when I sub the value in? M of the gradient. M of the tangent. So we get 3 of negative 1 squared minus 2 times negative 1 plus 1. So that becomes 3 plus 2 plus 1. So this time we have a gradient of 7.
6.
Okay?
6.
Oh yeah, 3 plus 2 is 5. So we have 6. That's an ugly 6. There we go. Now, do I have enough information to find the equation of the line now?
Yes.
Yes, I do. So I've got a point here, and I've got my gradient. So that's enough. We can find the equation of the line now. So we use the formula y minus y1 equals to m x minus x1. So y minus negative 4. And obviously those of you who are quick with your substitution, you don't need to go to this length. I'm just being extra careful for those who need to review. X minus negative 1. So y plus 4 equals 6x plus 12. And let's just make y the subject. And there you go. That's the equation of your tangent.
Sir,
Yes.
why is it plus 12? Isn't it plus 6?
Oh yeah. I can't multiply either. Alright, plus 6.
No, it comes to 2.
There we go. Okay, so that's the equation of my tangent. Alright, so guys, first step, like as you can see, we do have the point given to us, so there's no need to find the point. But we need to differentiate this in order to get the gradient, correct? So what we do, dy dx, and we get 6x minus 2. Now, again, dy dx is in terms of x, so I only need the x value from the point given. So sub x equals to 2. Now, once I sub it in, dy dx, we write it now as mt, so the gradient of the tangent. Because it is no longer a gradient function, it is now actually a gradient once you sub the value in. So you end up with 10. So we've got a gradient of 10. I've got a point of 213. I have enough information to find the equation of this line now. So y minus y1 equals to m, x minus x1, and just sub everything in correctly. And make y the subject, 10x minus 20 plus 13. So y equals 10x minus 7. And there you go. Easy? Inshallah. Alright, let's try the next one. Actually, has everyone finished the next one?
Yeah.
Alright, let's just do that real quick, and then we're going to move on to the normal. And I'll explain what the normal is to you guys.
Y equals negative 21x plus 31.
So dy dx, actually before that, because I don't have the y value, I want to find the y value first, okay? So sub in the x value into the equation. So sub x equals 3 into y. Whenever you want to find points, guys, don't forget this. When you want to find a point, sub it into the original. The original is always the y equation. Okay? So y equals to negative 4 times 3 squared plus 3 times 3 plus 2. And what does that give us? Minus 25? Okay, so therefore I know my point is 3, negative 25. Okay? Now, with that, we will go on to differentiating the function. So dy dx equals negative 8x plus 3. We good so far?
Yeah.
Negative 8x plus 3. Now, what must I sub in to get the gradient? Yes, so sub in x equals 3. So sub x equals 3. That makes it the gradient of the tangent now. So that's negative 8 times 3 plus 3. And that will give us negative 21, correct? So now I've got my gradient of my tangent. I've got a point. Now I can use the point gradient formula. So y minus negative 25, which becomes y plus 25, equals to negative 21, x minus 3, y plus 25, negative 21x plus 63. And just subtract that 25. You will end up with 38. All good? Okay, excellent. Now, let's move on to the normal. Let me just, yep, so the normal. Yes, I've put up the revision lesson from the holidays, and I've also put up our previous lesson. This will be up today as a raw note, but this one will also have the video. Okay? Yeah, it's in the, if you go to your tuner folder, you'll see a new folder called UGC Lessons. And in due time, I will sort them out properly as well. So week 1, week 2, week 3. That way you've got everything sorted for you as well. Okay, so now normals. Now guys, pay attention to what I'm about to define the normal as. A normal is a straight line that is perpendicular to the tangent. At a given point. Alright, so a normal is just that straight line that if you have a tangent, you just draw the line that's perpendicular to it at the same point. Okay? So let's look at that visually. How does that look? You got some graph here, some function, y equals f of x. And then here's our given point. Here's the tangent. Okay? We will say this has gradient mt. Now, here's the normal. Look at the normal. It is exactly, oops, It's exactly perpendicular at the same point. See that? At the exact same point, it is perpendicular. We're going to call this one MN. I'm sure you all understand what the N's for. Gradient of the normal. Now, what's the rule for perpendicular gradients? Who remembers? Yes, so that's the trick. What's the rule? The mathematical definition.
Reciprocal of the negative.
M1 times M2 is negative 1, or you can also say M2 is negative 1 over M1. Okay, but in the language we're interested in, we're going to say the gradient of the normal is negative 1 over the gradient of the tangent. Now, the way I like to do these perpendicular gradients, I just like to, watch this guys, I like to negate, see the negate? And then I like to reciprocate. So I just put at the bottom. Okay, so negate and reciprocate. Okay, now finding a normal is almost identical to finding a tangent, except you've got one extra step squeezed in between steps 2 and 3. Okay, so let's try an example. Find the equation of the normal to the curve y equals to x cubed minus 3x squared minus 2x plus 5 at the point negative 1, 3. Can someone just quickly do a calculator check to make sure my x value matches? Okay, so that's the point we've got. Now let's run through the steps. So step 1. I don't need to find the y value because the y value is given to me. So the first step I can do is find the gradient function.
Yeah, so.
Yep, alright. So find the gradient function, meaning I just have to differentiate the y. So dy dx equals to 3x squared minus 6x minus 2. So now I've got my gradient function. What should I sub in now? So sub x equals negative 1. I know you want to say something else, don't. So sub x equals negative 1. Watch this. I will get the gradient of the tangent. And this is actually step 2, by the way. Let me write that as well. So step 2. Find the gradient of the tangent. You actually need to find the tangent's gradient, guys. So now that you've got the gradient of the tangent, hold on, 3 negative 1 squared minus 6 negative 1 minus 2. So we end up with 9. Oh, sorry, is that 9 or 7? 7. Okay, so the gradient of the tangent is 7. But the thing is that I don't want the gradient, I don't want the equation of the tangent this time. I want the equation of the normal. So we need to add in one more step, guys. Huh? No, hold on. What you do here, find the gradient of the normal. How do we define the normal, guys?
Perpendicular.
It is perpendicular to the tangent. So I can use negate reciprocate. Yes, the normal is always perpendicular to the tangent. So that means that the gradient of the normal is negate. And what's the reciprocal of 7, guys? 1 over 7. There you go. That's the gradient of the normal. It's that simple, guys. That's the only step you need to add in to find the equation of a normal. We good so far? Now we find the equation of the line. So we're using the point gradient formula. Alright, so y minus y1. Our y1 is up here. That's 3. So y minus 3 equals to the gradient of the normal. So negative 1 over 7. X minus negative 1. So that's plus 1. Now, question guys. What's probably the best form to write this equation in? I think general form would be best here because I don't like fractions. You can clearly see that x will have a fraction here. So I'm just going to go ahead and write it in general form. So I'll multiply both sides by 7. So what I do is I multiply this side by 7. And I do multiply this side by 7. But what happens is that 7 cancels out straight away. Okay, so we get 7y minus 21. And be careful with this negative here, guys. No, it's fine whatever you do. Watch out for this negative here, guys. Okay, that negative is going to expand into that bracket. So I end up with negative x, negative 1. Okay, it swaps the signs of everything in there. So make sure your algebra is on point here. Now, general form requires the x to be first and positive. So I'm going to move this x to the left side. So we end up with x plus 7y. And I'm going to move the negative 1 as well. That'll make it negative 20. And there's the equation of my normal, guys. Got it? If the question asks us to sketch this, how would you sketch a line? You should remember this from functions. What do?
You make a
X-intercept, Y-intercept. Okay? So, actually, let's do that right now real quickly. So if I have, if I want to find these, the way this equation looks, I let y equals 0, so that will give me x is 20. And then I let x be 0, and that will give me 20 over 7. So the graph will look something like this. Now, it's not to scale, but that would be a lot shallower, okay? Because it has a gradient of 1 over 7, okay? It should be a lot shallower than that. But now we know the gradient of the tangent. Of the normal. And the way that it would look through the graph, our point is negative 1, 3. It'll cut right through it somewhere there. Okay. Now that's when you are given the points completely. Now, how about we do it if I just give you an x value? So question 2. Find the equation of the normal y equals to. Alright, so 3x cubed minus x plus 5 when x equals negative 2. So I want to find the normal here. Now, guys, same procedure. If I only have an x value and I'm asked to find the tangent or a normal, I need to find that y value straight away. So I'm going to sub it in. So sub x equals negative 2. That will give us y is equal to 3, negative 2 cubed, minus negative 2, plus 5. So that will give us negative 24, plus 2, negative 22, negative 17. Right? Can someone double check that, please? Therefore, negative 2, negative 17. So that's the point that we're going to be using. Now we need a gradient. Okay, so let's differentiate this function. dy dx is 9x squared minus 1. Okay, so 9x squared minus 1, this is our gradient function. What should I find first regardless?
The gradient
of
the tangent.
I have to find the gradient of the tangent. So sub x equals negative 2, and I have to sub in the gradient of the tangent. We end up with 9 bracket negative 2 squared minus 1, and that will give us 35. So this is a very steep gradient for the tangent. What does that mean for the normal then?
It's going to be
very small.
It's going to be very shallow. Okay, so if the tangent is steep, the normal will be shallow. So now let's just do the negate reciprocate method. So we get negative 1 over 35. You see that? I just put a negative and I flipped it. Okay. Have I met the requirements to find the equation of a line now, guys?
No.
Yes, I have. So y minus negative 17, so y plus 17 equals negative 1 over 35. And then x minus negative 2, which is x plus 2. Okay, again, I will put this in general form because I don't like the way a fraction looks. So we end up with 35y. Can someone please do 17 times 35?
595.
595. Again, take note of the negative there, guys. Don't miss it. It will negate everything in the bracket. So negative x, negative 2. Okay, then just put the x as the leading term. And you are done. Again, if the question asks you to sketch this, you saw the procedure in the last example. All good?
Yeah, x is negative 500.
Okay, so yeah, it is.
So, but in the exam, there'll be like nicer numbers.
Oh yeah, I just made that up. That turned out to be horrible. All right, now let's do. Let me give you guys 2 questions similar to the ones I just did. So find the equation of the normal. To the curve y equals to x cubed minus 3x squared plus 2x minus 5 when, oh sorry, not when, at 2, I'm going to do this real quick.
2x minus 1.
Wouldn't be negative 5.
Oh, I have no idea. Negative 5, perfect. Yeah, I'm going to fix it up now. No, it's 5. Okay, so that's the point. I want you guys to find the equation of normal. Go ahead. Okay, so let's find the. Hey, why is that thing there? All right, let's find the equation of the normal to question 3. So dy dx equals to 9.
No.
3x squared
The-
minus
and
6x
one
plus
step,
2.
What was one step again?
Shadi, your voice is on the thing now. Keep it down. Now, 3x squared minus 6x plus 2. Now, you have to find the gradient of the tangent. So sub x equals 2. And you'll end up the gradient of the tangent to be 3 bracket 2 squared minus 6 times 2 plus 2. Okay, someone just verify my answer. It's 2, right? Okay. Now, that's the gradient of the tangent, but that's not what I want. What do I want? I want the gradient of the normal. So we negate, reciprocate. Minus 1 over 2. Now, do I have enough info to find the line? Yes, I do. So y minus negative 5, which is y plus 5, is negative half x minus 2. Okay, so I don't like fractions once again, so my preferred form for a fraction question is to multiply by the denominator. So we get rid of this 2. Yep, so we get 2y plus 10. And take note of the negative again. I'm going to keep emphasizing that. It's going to swap everything in there. So what does it become? So minus x plus 2. And I like general form here. So x plus 2y plus 8. There's the equation of your normal, guys. Okay, let me just move this up.
So our problem is absolute. Absolute.
Huh?
Yeah, I think not.
My parabola. It's a big chat.
Okay, so how do we go with the part 4?
Yeah, very nice.
Got it?
Yep.
All right, let's just let's get the first main part going. Now, once again, I noticed that x is lonely. I just have x equals 4. I don't have the y value, okay? So I'm going to find the y value first. So y is equal to 3, 4 squared minus 8 times 4 minus 12. Can someone verify the answer for me, please? It's 4, yeah? So therefore we have the point for 4. Now, from here, I need to differentiate. So dy dx, we take this and we differentiate it. So 6x take away 8. And then I need to sub in this x value here. So sub x equals 4. This will give me the gradient of what, guys? Of the tangent. Yes, you're right, it is 16. That's not what I want. I want the gradient of the normal. So this is negative 1 on 16. Okay? So now I've got enough info, I've got a point, I've got a gradient. Let's find the equation of the normal. So y minus 4 equals negative 1 on 16, x minus 4, and you guys know the rest of the process. Okay, so 16y minus 64, negative x plus 4, x plus 16y minus 68 equals 0. There we go. All good, guys? Oh, wait, we've got to sketch it now. I forgot about that. I didn't. Huh? Yeah, it's much better. I'm not as messy. Okay, so now let's find the. Let's have a look at how this line looks. The parabola. The line I'm fine with. I'm just going to use the x-intercept, y-intercept method. So let's do that real quick first. So x-intercept, guys. What do I do to find the x-intercept? Let y equals 0. That's correct. So we get x plus 0 minus 68. So x is equal to 68. What about the y-intercept? What do I do? So let x equal 0. Now, again, so you get 0 plus 16y minus 68. So 16y minus 68 equals 0. 16y equals 68. And y is equal to?
68 on 16.
What does that become?
17 on 4.
That's for the x.
17 on 4.
See what I have for the y.
Okay, so now I know my x and y intercepts. And I can sketch that once I get my my parabola going. Now I want to sketch this one, guys. That graph. I'm going to start off by getting the axis of symmetry. So let's look at that. So 3x squared minus 8x minus 12. Axis of symmetry.
Then you can do x and 1.
Yeah, that axis of symmetry is x equals negative b on 2a. No, not unless I can factorize or solve it. I'm not bothered to solve it, so I'll just go with the axis of symmetry straight away. So that will be negative of negative 8 over 2 times 3. So that's 4 on 3, isn't it? So that is my axis of symmetry. With this, I can find what? The vertex. Very good. So the vertex, I sub this x value into the parabola. So sub x equals 4 on 3 into y equals 3x squared minus 8x minus 12. Has anyone done that? What is it? Minus 52 over 3. So therefore the vertex is going to be this point here. So 4 on 3 and negative 52 on 3. We good? Okay, so we've got that now. We know it's concavity. What concavity is it? So this is concave up. Do we need to know anything else? Let's check its discriminant to see if there are any roots. Alright, so delta is equal to b squared minus 4ac. I'm just checking if there are roots, guys. And it looks like there are. I'm going to have to find it. Okay, so let's find the roots. Now, it looks like I can't factorize this. Is that right? Yeah. Okay, so what I'm going to use, because I can't factorize it, I'm going to use the quadratic formula. So x equals minus b plus minus square root b squared minus 4ac all over 2a. That is in your formula sheet. You don't need to memorize it, but usually a student who does study a lot, they'll memorize it by accident, which is a good thing. So let's use the formula now. So b squared minus 4ac. Yeah, I memorized it by accident. I also went to hospital because of it. But yeah. Anyway. Yeah, I was studying too much. So what do we get? 8 plus minus. Can someone do the square roots for me, please? And we get 6 here. Come on, Shady.
64 plus 144. 210. 200.
Close. 228, I think.
Yeah.
228. Shady, hurry up. We're depending on you.
228.
There we go.
I guess that was.
No, I can't write that in.
Huh?
Huh? 208?
Yeah, dude. Did that.
What'd you get? Put brackets
208.
Times
Pretty close. Alright. So I can see my two values are x plus square root 208 over 6 and x equals 8 minus square root 208 over 6. Now guys, you should get an idea of what these answers are. So it's recommended just to find an approximation on the calculator. So someone do the plus case, someone do the minus case, and just give me approximate answers. Give me about 2 decimal places. Is that the plus one? 3 point? Yep, and what about the negative case? -1.07? There we go. Alright, so I've got an idea of where to sketch this now. Okay, so we've got all this space to draw our graph. Let's recruit all of our information. Wait, I may need more space. Okay.
So you found the y-intercept?
Yes, -12. So let me just write that there. Y-intercept is y equals -12. Okay, so I think the parabola is harder, so we'll start with that. Its vertex is at 4/3, -52 on 3. Remember, you don't have to be a perfectionist. We'll just say that that is 4 on 3, -52 on 3. Zach, incriminated. Alright, now. Alright, so we have -12 intercept. And then we got the x-intercepts. There we go. My line's a bit wonky. I have to fix it.
He says wonky in that.
That's right.
Okay. So now, let's do the, let's put in all our key points. So this one here is 8 plus square root 208. And that is 8 minus square root 208. And this here is -12. Okay, so once you've got all the key features in, by the way guys, this is a reflection on quadratic polynomial, so you need to, it's good to visit back to the old topics. Now let's sketch the normal, sorry. Now this normal was at the point 4,4. 4,4. Okay, because of the way I've drawn, I'm gonna sort of exaggerate it. So that there is 4,4. I'm gonna draw the normal here. Keep in mind not to scale, guys. Now, if I look at this real quickly from a tangent's perspective, the tangent will be going like this, right? Can you all see that?
Yeah.
The tangent's going that way. So the normal has to be perpendicular to that. Okay, and as you can see, the x-intercept doesn't fit on the screen. But if we look at the y-intercept, you can see the y-intercept is 17 on 4. Correct? And look at the x-intercept. It says it's at 68. So that makes sense that it's all the way down there somewhere. Okay? Does that make sense, guys?
Yeah.
You know that somewhere down there it's going to intercept at 68. Okay, and there you go. That's the full question answered.